back to Go with Marley. Today we are going to be working on our plane. Last time, which was 2 videos ago, not one like usual, because now I'm also teaching iOS. Well, I'm still finishing up here, but still. We were coding this. We were putting the code into it, but we haven't wired everything up yet. So let me get a good view. All right. So today we are actually going to wire it up. And as you can see, I already have a few wires that I already connected off cam. That's okay, because you should be able to understand this. All the grounds to ground, all the 5 volts to 5 volts, okay? Except the DC motors 5 volts. That there we want to connect to a PWM digital pin. But for now, all we're going to do is get wiring. And this is going to be a very simple one. That's why I'm also going to do the joystick stuff in here. But 2 videos, we will be actually coding the joystick. And then after that, we are going to connect it to the IoT cloud. Let's see. What's the right one? Anyways, so let's just get into this. First of all, what we need to do is take this servo, and we have the signal on all the 3 servos. And guess which one is the main motor? You guessed it, the one and only motor that's here. And actually, I might as well connect emergency motor. That's what I was gonna do, but then I forgot to write it in the code. So for now, we'll cover that real quickly in the joystick video on the way beginning. So DC motor, DC motor. And they also have DC motor with encoder, DC motor with, they have 2 different ones actually with encoders, but that's a little more complicated. And I would like to see how to use this. Channel B, encoder power, motor positive, channel B, encoder power, encoder ground, channel A, and motor negative. This is all kind of confusing, but for now I'm gonna add the emergency motor. So guess what? Ground goes to the grounds. Very, very simple. So for now, all we're gonna do is we are going to connect. So this is gonna be the left motor, the right motor, the rudder motor. These are servos, the left wing, right wing, and rudder, which turns it. Helps turning at least, but still. For now, all we gotta do is connect orange, okay? So we're gonna take the signal here and connect this to from the servo one. Make sure that these are not PWM, because we're gonna need other PWMs later. For these 2 motors, we need PWMs, but yeah, you can use them, but still, I don't recommend that because PWMs are meant for PWM usage. But still, if you want to, then go ahead. And do not connect anything to TX and RX, because those will be for the ESP8266 or 32 or whatever really works, okay? Anything will work. Now, for the rudder, and we're going to have to... Oh, actually, no. This is not how we did it. We need to connect these to the right one. The left one was on 7, or... I'm not very sure. Now, this was on 8, I think. No, this was 7. This was 7. And the other one was 8. Sorry, guys. Forgot that it was even like this. Then we have... and this motor here, main motor. I'll do this, the motor's yellow. And then that's going to be on D9, which is digital. No, this was D10, remember? And the rudder was 9, I think. I'm going to have to double check, okay? But if you notice anything wrong, go ahead and fix it, okay? Go back to the other video, and if you by chance already remember now, go ahead and do that. But... Oh, no, this is orange. This is the rudder. I don't remember. I think the rudder was on 9, but I cannot be completely sure about that, okay? Cannot be completely sure about that. The only thing that's an emergency, I'm gonna have, let's see, this here looks like emergency color. Not really, but Yeah, red is usually it. Actually, no, green is actually widely used on signs. Exit, even though red is also used, but still. Now, the emergency motor is going to be on number 11. I mean, not 12. What am I thinking? And also, since this seems very short already, I might as well already cover what a diode does. Diode. There we go. And photodiodes and other things we'll cover up later on, and as well as a capacitor. Now there's another kind, which it's a polarized capacitor, which things we'll use. I'll just show you how it works. Polarized capacitor, but it's a lot bigger. But for now, polarized capacitor and a normal capacitor, they just store voltage. Usually what you're going to do is you're going to connect the positive, and then you're going to connect from from the battery. If there's a battery, you have from the battery to the capacitor, and the other side goes to the electronics, whatever you're using. Or you can actually connect this to positive and negative, but that there will take some time to charge up. That's why I recommend using the capacitor there. Now the diode, rotate this a little bit. It only allows electricity to flow one way, so anode and cathode. Anode is where the electricity comes in, cathode is where it comes out, okay? So, you can also check by the line. So, if I had AC voltage, and I want one of them doing alternating from positive to low, to positive to negative to positive, and the other one I just want it to be a steady current, then I can just go like this. And actually there is a way to turn, let me show you here. There is a way to turn AC into DC using an inverter, and I'll show you how to make one. Simply like this. So you have the anode, let's see, let me try to remember if this is the right way to do it. I don't know. Oh yeah, that's here gets rotated. I think that's it. Let me double check. So if electricity comes in, it'll go through there. I'm not very sure, but it's some kind of setup that's this kind of shape. And if you put electricity into one side, AC voltage, it'll turn into a DC. Let's see. So if electricity goes through as a positive, it'll go into here. If it's a negative, then it won't. Instead, it will go nothing. Now, the other one, you don't want, you only want the, This is getting kind of quite confusing. Anyways, let's just leave that alone. Let's get into the joystick, okay? And whenever you probably think of joystick, even in my thumbnails, I actually have a picture of a gaming joystick. And if you guys play computer games, you should know what those joystick things are. So let's just say that the plane is inside the computer game, and we are controlling it with our joystick to turn the plane, and our goal is not to crash into anything. Understand? Now, anyways, let's go into, this is also plane, but for now we're just going to change into the joystick mode. See it in the joystick connectivity. Even though this does look quite confusing, that's why I do recommend you go from start to finish instead of just skipping to here, for example, and then checking what the diagram is, because you're not going to be able to see completely through this, okay? Diagrams are not very useful unless it's very simple and that's there, and wires aren't overlapping each other, okay? So anyways, let's go into the joystick. Oh, and by the way, I was going to quickly show you how to do this. If you're in Tinkercad yourself, you're usually open up in 3D Designs, but for now, if you switch to circuits here and press create new circuit, not circuit. I don't know what I was saying there, but for now, if you go like this, then what will happen is you'll get a new one, and there's usually a funny name, Epic Jabin Lahdini. I don't even know what that means. Now let me change this to joy stick. And for now, what we're gonna do is also we're not really gonna use an Arduino Uno. We're gonna use, well, actually we can. Yeah, we will. We'll connect an ESP8266 to this stuff. And I don't think they have this ESP anything. No kind of ESPs. But we have something else, okay? That has it, okay? To show you the diagram and how to connect it. I'll connect it for you. Except that the reason that I'm using Tinkercad instead is because you can simulate it. Start simulation will work. Yeah, this is gonna take some time. Sorry. Reload. But yes, what you can do, it's actually very simple, is go to Tinkercad, create that as the computer. That's how big I can make it. But for now, I recommend you get a Tinkercad account. Also, my games will be using it, okay, that I'm making. If you haven't heard about CWM Games Beta, then go ahead and check it out. And also, I just published my video on my website, codewithmarley.com. But for now, sorry about all this talking. All we're going to get in now is actually doing it. So what we need is a joystick. Joystick. They don't have joysticks in Tinkercad? Okay, I'm just going to pretend that there's a joystick, okay? So I'm going to take a couple of resistors. Make it look like one, even though it won't really look like one. If that makes any sense. Try to make it look as good as possible. And then this here will be, yeah. Okay, I know this doesn't look like a joystick, but I'm just gonna add a couple notes to show. Volts 5. I know, it's kind of annoying. They don't have, I hope they'll add joystick soon, but I'm pretty sure they will, okay? Now, sorry again. So 5 volts, GND, note. 5 volts is here. Ground is here. Then comes SW or WS, I think. I think it's WS. I'm not very sure. That's the last one. That there shows if the joystick is getting pressed. If you play some games you need to press down on it on your joystick. Like you need to press like a push button pretty much down. That's actually how it works too. There's a push button under it. For now, yes, it can be like that. And then we have X. And I don't think it's XPause, but for now I'm just gonna have XPause. But for now, you can see, okay, what it's really called. But you can figure out what Y pause and X pause is. What I'm really trying to say right here in these. I'm gonna spread this a little more out. That way, when I zoom out, these things won't get humongous. So like this. Y pause. That's a good spot for it. And that. Those two are here. Sorry. But for now, all you can check is how a real one looks, and then you can see. And you can download these in the description. I'll actually show the link right now. But for now, yeah, that's a little bit still squishy. It's okay though. So first of all, 5 volts and ground, of course, you know what to connect those to. But now you should probably have those connected, if you have one at home. If you're just watching my videos, I recommend you actually get an Arduino and start doing this. Or if your mom and dad say that if you guys are ordering it and it's on the way, you can use Tinkercad in the meantime. Like I'll have a link in the description, even though you can just go to tinkercad.com. But still, I'll have it in the description. But not only that, you can also go ahead and if they say no, go ahead and just see if there's a way for you to get this, because it's all that I'm really trying to teach you, how to make an actual robot And once your mom and dad notice that you're actually making a robot on a computer, of course they're gonna buy you a small little kit. But even if it isn't everything that you need, I am sure you can figure it out, okay? And yeah, anyways. Now the Y position, we're gonna connect to an analog one. I'm gonna do a 1 for the Y position. And then the X position, which we'll see how much left and right we're going, a 0. Now WS, green I think, yeah, green. WS is going to be connected to the, let's see, where is it? Digital pin we need. I'll do digital pin, let's do 2. 2 is a nice one, okay? I know it's not my favorite number, 8, I'll do 8. And the reason why I'm doing 8 is because that is my favorite number. Let me know in the comments what your favorite number is. Really like to know. And color and music or stuff like that, okay? Because I'd really like to get to know you, and maybe you can come to my house sometime. Okay? You'd be very happy about that. Seeing I've been doing this for over a year now, okay? So you'll be quite surprised about what I know. But still, it'll be okay. No need to feel like you don't know anything, but still, you'll get there, okay? If the time you meet me or you watch this video, I already have the robot one out. Then, well, if you watch the robot one, then I guess you should be able to know enough. If you watched all my videos so far, I hope you'll understand. If there's any questions, by the way, let me know. But for now, this is what we got. And I'm actually going to have 2 other LEDs. Red one and green one. Green one. And in our case, what the WS will be, which is when we press down, that there will be having the speed. So speed. Turn on the speed. And I'm going to have the speed being blue. Actually, no, I'll do white. So that there lets you know that we're on full speed, like real fast. But that's the speed that we're going at, okay? So for now, we're going to connect the grounds. Which one's the short? What does the short leg do? Yep, negative. What's the long leg? Positive. Even though it does say anode and cathode, but for now we're completely okay about that. Alright, but for now, we got all this done, and actually, if you ever hear a light emitting diode, they're talking about LEDs. Because these are really LEDs. I mean, these are really diodes that just make light, which might be quite confusing to you. That's actually why I already explained just now the other one. That we are going to, what's the right color? I love red on this one. Do they have red? Not very sure. Nah, I don't want to use red. I'll use white. I'll use white for the super speed. Oh, I can't really go to white. I'll just do brown. I can't really use white with my keyboard. And if you want to see the shortcuts, what I'm really doing, I'm pressing 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. But then we can't do everything, okay? We can't go up. You can go up to brown, but yeah, I don't think you're really going to want to use white or so. Or gray. But still, if you really want to, then go ahead. White is actually quite hard to see. Might as well just go to gray then. So, even though because it actually does look gray in the beginning, but for now we have that, and then we have cyan for off or not connected. This is going to be for connectivity, okay? Not connected, connected. Okay. Not connected, and then connected. There we go. Sorry I've been so quiet. I'm so used to being so quiet right now. But for now, there we go. We got our joystick done. My computer. If you ever hear a sound like this one here, The sound should be up then. But if you ever hear a zzz kind of sound, that's probably my computer fan. But by that time, I usually will have it stop. And then after my video, I usually turn off my computer to make sure that my computer doesn't burn up. Because this is quite valuable to me. Having a Mac, not many people would be, a lot of people would be surprised that a 10-year-old has a Mac, okay? And if you don't have one, that's okay, okay? You don't need to have a Mac. You can use whatever computer to code. And this actually works on your tablet or phone will work too, okay? And if you don't have that either, it's okay. Alright? Whatever you're watching this video on, you can do the exact same thing on that I'm doing right here. You can follow along in tinkercad.com. And you can do a lot of things. And actually, from now on, I'm going to share these projects. That way you can actually see the diagram and you can test it out even though the joystick ain't gonna really work. And so will the play not, because they don't have ESP8266 this year. But if you want to check out my Blink or anything, let me actually go back there. Blink, how do use potentiometer? Sorry, that might be it. Blink, all kinds of things, okay? What is the push button and how does it work? I know these aren't in thing, and most of these are private, okay? So, Blink, if you want to test this out, press simulate. And I'll actually share this for now. You press on simulate. Here we go. Then you can even check out the code that I put in here, okay? You can copy the code from here. And then you can run it. Press start simulation. And as you can see, that thing turns on and off. And if you want, you can actually go here. Okay? You can use this. Nah, I don't think that works. But if you go to the last one, you have this here, which is the circuit. Then you have this, which is going to take some time to load. But for now, I'll show you this later. Oh, here. Okay, so this is just in. So hard to see. Yep. This here actually shows you what happens, even though you can't really see a lot of things. And then on the way end, this here shows you everything that is inside here. Even shows you how much, the name of it, which I seem not to be really doing. But for now, it shows you what it is. Arduino Uno R3, yellow LED, orange LED, blue LED, white LED, even though all of these here aren't in use. The white LED we're using, we have a 220 ohm resistor we're using. That's what we're using, R1. Green LED, we're not, and so are we not using the red LED. And you can actually, I think, but I'm not completely sure. But I'm pretty sure that you like this. Nope, not on Facebook. But yes, you can check out everything that I'm doing, okay? I actually just opened up my blog, even though I'm not really writing it. Sorry guys, but still. I'll be writing in it real soon, alright? See you guys next time though. Bye! That was a long one.